Okay, so the last bit of circles that we're going to do are parts of circles. Now you can do this if you've done sectors already. You can do it the same method as sectors because you should know how many degrees are in each one. So for example, if you had a quarter of a circle, I've written the right angle, so that's 90. This would be 180 because that's a straight line, and this would be 270. Okay, so you can do it the sector way. I'm going to show you another way of doing it just because this is generally a bit quicker and a little bit less effort, and also sometimes in the future you won't need to write your answer. You don't need to use a calculator, you might need to write your answer in terms of pi, so you might need to do this in your head, whereas if you're doing the fraction way or the sector way, it might be a little bit more confusing because you've got the fractions. So right, we're going to start with this first e.g. So we've got, if we look at here, we've got a quarter of a circle. Now the biggest mistake that people make is that people aren't aware of actually what this 6 represents. So this point in the corner of our sector is the centre of the circle. Okay, now because that's the centre, that means that the length from the centre to the outside, or the circumference, would be the radius, so the radius is 6. Okay, we are finding perimeter as well, so I'm going to work out the diameter as well. So the diameter is the radius times by 2, which is 12. That's going to be important later. We're going to start with the area, just because the area is actually much quicker to find. Now, when you do these, just do it to start off with as if it was a whole circle. Okay, so to find the area of the whole circle, we do the radius squared times by pi. So we know the radius is 6, so we're going to do 6 squared times by pi. And then we can type that into a calculator and see what it gets. 6 squared times by pi, 113.1. Now the issue is, again, we don't want the whole circle now. We only want a quarter of it. So all we do with our answer is divide it by 4. I'm not sure where I'm going to fit all this. So your answer should still be on the calculator. So if you just click answer, it's quite a good method because it keeps all the decimal places that you need. So answer divided by 4, 28.3. Okay, so that's the area. Okay. So the perimeter, first thing we need to do is find this curvy bit here, which is called the arc length, if you've watched the sector one already. Arc length. Okay, so again, you do exactly the same thing as just finding the circumference. So circumference is the diameter times by pi, so 12 times pi. Which gives us 37.7. Okay, we only want a quarter of it, so we then need to divide our answer by 4. I'm going to run out of space. I'm going to do it up here. So yeah, again, if you just click answer and then divide by 4, 9.4. So the arc length is 9.4 centimetres. Now again, we want the perimeter, so we've worked out this curvy bit. We then need to add on 2 lots of the radius because they're what the straight edges are. So the perimeter will be 9.4 plus 6 plus 6, 21.4. Yeah, 21.4 centimetres. Okay, so it's not that difficult. You've just got to think about, one, starting off with just finding the area or the circumference of the whole circle, then just divide it by So for this one, obviously we've got a quarter. If you had a half, then you divide it by 2. 3/4 is a little bit fiddly. Just find 1/4 and then times by 3. So just stuff like that. Okay, I'm going to turn over. We're going to do another one. Oh, it looks like a little rainbow. So for this one, we've got 2 half circles, one that's inside the other one. The dot here in the middle, I know it's a little bit faint, that is just where the middle is, or the centre of both the circles. Okay, so we know what the radius of the first one is. We know it's 2. Now the radius of the big one, it's trying to trick you really. A lot of people will think it's just 3 because that's the bit that's there, but actually the radius of the big circle would be those 2 added together, okay, which would be 5. So again, I'm going to start with the area. So I'm going to find the area of the whole thing, so the area of the big semicircle. Then I'm going to find the area of the little semicircle and then subtract them from each other to then work out the area of just the shaded bit. So for the big semicircle, we've got a radius of 5, so it's going to be 5 squared times by pi, and because it's a semicircle, we've then got to divide our answer by 2. Okay, so 5 squared times by pi, and then answer divided by 2, 39.3. Okay, then we're going to do exactly the same method but for the small one. Okay, the only bit that changes is the radius, because the radius of the small one is only 2. It's going to be 6 point something. Yep, 6.3. Okay, so the area of the shaded bit is just going to be these 2 answers subtracted from each other. So 39.3 subtract 6.3, which would give us 33 meters squared. Okay. So for the next bit, it's actually a similar method. So I'm going to find the circumference of, or the arc length of the outside one, and then I'm going to do the same for the inside one, because we're trying to find the perimeter, so we need to find the length of the big one, the length of the small one, and then we're going to add on these 2 little bits here. So again, I'm going to start with the big one. So the circumference of the whole thing would be the diameter times by pi. Now we've said the radius of the big one is 5, so the diameter must be 10. So it'd be 10 times by pi. And again, we need to half our answer because it's a semicircle rather than a whole circle. So 10 times by pi, and then divide that answer by 2. 15.7. Okay. Then again, exactly the same method for the small one. So we've got a radius of 2, so the diameter will be double that, so it'll be 4. Okay, type it into a calculator and that will be 6.3 meters. Okay, so then when we're trying to find the perimeter, we then need to add all the bits that make up the perimeter. So we've got the big curvy bit, which is 15.7. We've got the smaller one, which is 6.3. We've also got these 2 bits here. Now we know that this one's 3. This must also be 3 because they're identical. They're symmetrical on both sides. So plus 3 plus 3. We add those together. And we get 28.0. So I'm just going to write 28 meters. Okay, so they're not that difficult, it's just doing it all in little steps. Make sure you don't rush it and things like that, but other than that, it's generally okay.